All right, so we want to discover the distance formula to find the distance between 2 points and then use it to find exact distances. So I set up a coordinate axis here and I want to define the 2 points. And we'll just use subscripts, but maybe we'll call this point x sub 2, y sub 2, and this point x sub 1, y sub 1. So the distance I want to find is the distance between these points. And if you notice, I set up a right triangle because we're going to use the Pythagorean theorem to help us. So one of the things we need to find is the distance from here to here. And if you look at the x coordinates, this would be x sub 1, and this point down here would be x sub 2. So the distance between them would be x sub 2 minus x sub 1. So that would represent the distance of this side of the triangle. And then we also need to find the distance on this side of the triangle. And again, if we notice, the y coordinates actually represent the height. So this would be y sub 2, and this one would be y sub 1. And the difference between them, or y sub 2 minus y sub 1, would be the distance here. So again, the Pythagorean theorem tells us that the length of the square of the legs is the square of the hypotenuse. So if d represents the square of the hypotenuse, then the square of the legs, well, each leg a squared plus b squared, so maybe we can call this a and this b, then plugging this in, we got d squared equals a squared, which is represented by x sub 2 minus x sub 1. So that quantity is squared. Plus b squared, well, that's represented by the difference in the y coordinates, y sub 2 minus y sub 1. But the Pythagorean theorem gives us that, and if I just take the square root of each side, I would get d then equals the square root of x sub 2 minus x sub 1, the quantity squared, plus y sub 2 minus y sub 1, the quantity squared. So this is actually our distance formula, and it does use the Pythagorean theorem. So if we want to use this theorem to find exact distances, so the distance between these 2 points, so the first thing, I want to look at the x coordinates, and in the distance formula, I get distance equals the square root of, well, I need the difference between these, so it'd be 3 minus a negative 2, which is the same as 3 plus 2, and that quantity is squared, plus the y coordinates would be 10 minus a negative 2, so that'd be the same as 10 plus 2, and then that quantity is squared. So now we just need to simplify the square root, so d equals the square root of 3 plus 2 is 5 squared, plus 12 squared. This would be equals the square root of 25 plus 144, which is the square root of 169, and the square root of 169 is 13. So this one comes out exact. The distance between those 2 points is 13 units. So the next problem, again, we'll just plug the values in to the distance formula. So the distance equals the square root of, and again, maybe the x coordinates, 61 minus 55, that quantity is squared, plus, and then the y coordinates, 32 minus 29, and that quantity is squared. So the x and y coordinates are just used, simplifying d equals then the square root of 6 squared plus the square root. 32 minus 29 is 3 squared. So I get the square root of 36 plus 9, which equals the square root of 45. And the square root of 45 can be simplified. We have the square root of 9 times the square root of 5. So the distance then would equal 3 times the square root of 5. And again, this is the exact distance between those 2 points.